Hello, hello! We're going to do some more exponents today. Um, Last time we did a little review of basic exponents, so we talked about positive exponents. Alright, positive exponents. So I've got my little smiley, my positive emoji there. Today we're going to continue doing some exponents review, and we're going to add two things. Maybe you've learned them, maybe you haven't. So I definitely think for some of you it will be new. But we're going to do negative exponents. Negative. And we're going to do zero exponents. So I've got my negative face and then my zero expression face. I don't know if you like that, but I sometimes overuse these emojis. But I think it's worth it, and it's fun. So exponents. Positive, negative, and zero exponents. And we're going to continue to work on this goal of expanding and simplifying exponents and more focused on negative and zero exponents today. So let's start off with zero exponents. Well, let's go back. Let's just review a couple things. So exponents. If you're looking at an example like this, I'll circle it again in black now. 3 to the 7th power is how it's pronounced. The 7 is the exponent, the little number. That's how many times you multiply the base by itself. The base is the 3. That's a number that's being multiplied by itself repeatedly. And then the whole thing is called the power. And we talked about positive exponents last time and how to write them. We gave examples of when there's negative numbers in the base or outside of the base or parentheses. Remember this. The exponent should only be applied to what it is immediately touching, not something that's away from it. All right? So, and then we expanded them as well. We wrote expanded versions in exponent form. So if you want to look at those examples to refresh your memory on that, go for it, pause it. But we're going to go on and talk about zero exponents now. And here's the quote for zero exponents that you should have written down. Anything raised, oh, I already made a mistake. Anything raised to the 0 power is equal to 1. Kind of weird. When you think of something raised to the 0 power, maybe you think it's going to be 0. Maybe you think it's going to be the number itself. But really, it's always going to be 1. Remember, the same rules apply. It has to be touching. The base is the only thing that's touching the exponent. But, so if you have 5 raised to the 0 power, and by the way, I'm using carrots today, these little carrots right here, because carrots are healthy for you. No. But that's another way you can see exponents, using that caret. So that's 5 raised to the 0 power. The 0 isn't a small number, but if it has that caret, that means that's the exponent. Okay, I wanted to show that to you. So this is 5 raised to the 0 power. Guess what? 5 raised to the 0 power is 1, because anything raised to the 0 power is equal to 1. This is negative 1 raised to the 0 power. Now remember, this is technically the only thing that the 0 is touching is the 1. So that 1 raised to the 0 power is 1, and that negative has to stay out in front. So really, this one is actually going to be negative 1. Don't be fooled by the negatives. I'm throwing some more at you. Negative 6 in parentheses raised to the 0 power. So the 0 is attached to the parentheses. Everything in the parentheses is raised to the 0 power. So the whole thing is going to be equal to 1. There's nothing else. Next one. Again, we have parentheses around the negative 4. So that itself is going to be raised to the 0 power, which is going to be 1. But then we have this negative out in front that does not have the exponent attached to it. So this one is going to be negative 1. All right. 2 more. 12 to the 0 power. Well, it's just a 12 raised to the 0 power, so that's going to be 1. Now this one has a negative outside of the parentheses. So you have negative 12 raised to the 0 power. So again, since the negative is outside of it, it stays outside of it. Oh, I apologize. I was going to try and pause it before I sneezed, but excuse me. Where was I? Negative 12 raised to the 0 power. So if you look at this, if you cover up the negative and you just have 12 raised to the 0 power, that's 1, and then that negative is staying out in front. So this is a negative 1 as well. So when you have zeros raised to power, or 0 as an exponent, there's always going to be a 1 as the answer, probably. But it could be a negative 1, depending on where the negative is, if the exponent is applied to the negative or not. All right. That is 0 exponents. Anything raised to the 0 power is equal to 1. So let's go into the second thing. The other emoji was the negative emoji. So we're going to talk about negative exponents. And here's an example. 5 raised to the negative third power. That's what it looks like. Raised to the negative third is the exponent. All right, what does that mean? Well, let's look at some patterns, because patterns come up in math all the time. And really, a lot of things in math are determined because we're looking at patterns. So let's look at some patterns. Um, I have a whole bunch of exponents here. And again, I'm using the carets today instead of the small numbers next to it, the little superscript. But carets are healthy for you, remember? But anyway, 5 to the 5th power. I just have it all going down. I don't know if you notice. I'm keeping the same base, and I'm changing the exponent, just going down 1 all the way until we get into the negative. So let's see if it works out, if we can figure out a pattern. So 5 to the 5th power, I did it on the calculator already. It's 3,125. 5 to the 4th power is 625. We'll do a couple more. 5 to the 3rd power, 5 times 5 is 25. It's going to be 125. 5 to the 2nd power, 5 times 5 is 25. 5 to the 1st power, just 1 5 is 5. 5 to the 0 power, we said, is anything to the 0 power is 1. So before we get into the negatives here, let's look for some patterns. How do you get from 3,125 to 625? Or from 625 to 125, or 125 to 25? Well, it's everything. It's just dividing the previous number by 5. If you look at this, 5 divided by 5 is going to be 1. So really, this is 5 over 5. 25 divided by 5 is 5. So we're dividing anything. I guess the pattern that I'm seeing is just divide the number by 5. So let's do 5 to the negative 1st power. 5 to the 0 power is 1, so that's going to be on the top. And we're going to divide that by 5 to get this number. So if you look at it, you could change it to a decimal, but fractions I think are better. So we're going to keep it as 1 over 5. Okay. Now, we take that number and divide that by 5. What's 1/5 divided by 5? Well, let's take a look at this. 1/5 divided by 5. When you divide dividing fractions, recall we really multiply by the reciprocal. So 1/5 times, what's the reciprocal of 5? It's 1/5. So you get 1/25. So this is actually 1 over 25. Interesting. Actually, that's 5 to the 2nd power on the bottom, or 5 to the 1st power on the bottom for 5 to the negative 1st. Just putting it on the bottom. Let's see if 5 to the negative 3rd power will be 5, or 1 over 5 to the 3rd power. I think it will be. So really now we're taking 1 over 25, and we're dividing it by 5 again. Because our pattern is just dividing everything by 5. So 1 over 25 divided by 5 would be the same thing as multiplying by 1/5. So you have 1 on the top, and 25 times 5. You can check it, but it is 125. So we have 1 over 125. Okay? Now, I don't know if you recognize this, and maybe you did, maybe you didn't. I hope you did. But really, 5 to the negative 1st power is the same thing as 1 over 5 to the positive 1st power. 5 to the negative 2nd power would be the same thing as 1 over 5 to the positive 2nd power, because 5 squared is 25. So it's really 1 over 25. This one is 1 over 5 to the 3rd power. So believe it or not, and maybe this still looking at it is a little bit confusing to you, but we'll do more examples. But read this. Negative exponents. Here's the quote that I'd like you to take in, write down, whatever. A non-zero number raised to a negative exponent, so that's where a negative exponent comes in, is equal to 1 divided by that number raised to the positive exponent. So let's see here. I think I have some examples. 5 to the negative second power. It's equal to 1 divided by 5 raised to the positive second power, which would end up being 1/25. Let's say we have 3 to the negative third power. That's equal to 1 divided by 3 to the positive third power. So essentially, since we don't really want to work with negative exponents, to make it a positive exponent, which we know how to work with easily, you just put it on the bottom of a fraction. And if there's no fraction to begin with, you just put 1 on the top, which would be equal to 1 over 27, I think. Let's say we have 6. We'll say negative 6, how about, raised to the, we'll do negative second power again. So, to keep with the pattern, we're going to do 1 divided by negative 6 raised to the positive second power. So we still have 1 on top. Negative 6 raised to the positive second power would be 36, because negative 6 times the negative 6 is 36. All right, we can go on and on. What if you have 2? 2 raised to the negative fourth power. Again, we're going to put it on the bottom. Put that 2 on the bottom to make it a positive 4 exponent. And we just put 1 on top since there was no other number. Which 2 to the fourth power is 2 times 2 times 2 times 2, which I believe is 16. All right. So that's the trick with negative exponents. I do want to give you one challenge problem just to try for next time. And hopefully I'll be able to get to go through it next time with you, but if not, remind me. The example I'm going to give you is 1/2 raised to the negative third power. Okay, there is a trick with this. I want you to try and follow what we've been working with, but there is a little trick to go along with this to make it easier. See if you can figure it out. All right? And that's all we're going to do right now on 0 and negative exponents. All right? Remember, negative exponents, sad face, negative face. 0 exponents, anything raised to the 0 power is 1. We still have to keep in mind with those negatives and whatnot. But 0 emotions in that emoji. And then we've talked about positive exponents. So, go back, think about the goal, how you can expand and simplify exponents with negatives or positive exponents, or 0 exponents now, too. All right? And if you have questions, write them down and ask next time. Otherwise, have a fantastic rest of your day. See ya.